basically it is a molecular formula. If I divide by 2, divide by 2, divide by 2, here I'm gonna get C3H6 and then O like that. So do we have anything like this on this question? Yes, the answer becomes D. So that's how you could get your 2 marks. By the way, if you have any question, let me know so that I can address it as this class is live. Then let's go to number 2. Number 2, they're saying that which intermolecular force are present between molecules of this. So what is this molecule? You have to first identify which molecule is this. If you look at this last group, it shows that it is a what? It is either a ketone or an aldehyde. So if we take it to be an aldehyde, so it's going to be like that, and then the rest of this are just carbon atoms and then hydrogen, carbon and hydrogen, let me just call it alkyl group. So meaning that the number of carbon atoms are there, meaning that there are 7 of them. So which kind of intermolecular force of attraction which exists here? This is we experience here a dipole force, but carbon atom and hydrogen, it has what called the London forces. London forces. So it means that this molecule will have the dipole force. Look at which one has dipole forces, and then London forces only. There is no hydrogen bond here. Why? Because hydrogen is not bonded to oxygen, so hydrogen is scooped out. So the answer becomes B, and then you get your 2 marks there. Then we go to the next question. They're saying that yes, the structure formula, the structures of organic compound are shown below. Then they're saying that which of compound will decolorize bromine water. So here, I was emphasizing this when I was doing the final revision the day before, and then I was emphasizing this, that bromine water will only be decolonized if you have a double bond between carbon atoms or a triple bond between the carbon atoms. So basically you have to look at that. The double bond is there, but it's not between carbon atoms, so this is out. There is no double bond here, this is out, so the answer is supposed to be related to compound 2 and compound 3. So we come here, we find compound 2 and compound 3 becomes B. So B becomes the most correct answer. Yes, Kevin. Oh, you removed the message. All right. Let's continue to the next question, and then we see they are saying that which of the following statement best explain the role of catalysts? Catalysts, what do? They give an alternative. Basically, they give an alternative way in which a reaction can take place, and then in this alternative way, it increases. It means that it allows. It allows compounds to react faster. Yes, for example, you want to go from wherever you want to go. Let me just give an example. You want to go to Pretoria. You are from maybe Kasi, and then what happens? You don't have enough money for the taxi. What is another alternative you want to? You can use a train. So train becomes an alternative way. So it becomes a catalyst for you to reach Pretoria. You understand? From where you are coming from. Why? Because the price is a little bit what? Less. So when you look at it, you have to look at something which has lower activation, increase the concentration, provide alternative pathway with low activation, yes. But let's look at the last one. It increases the activation. No. So the answer becomes C. So C becomes the most correct answer. Then let's go to 1.5. They are saying that the energy distribution curve for a fixed mass of a gas at 2 different temperatures. So in this case, what are you looking at? 2 different temperatures, okay? What's the question? Which one of the following is correct interpretation of the curve for change in the temperature T1 and T2. T1 and T2, okay. Let's look at it. Activation energy, what about it? Stays the same. Activation energy stays the same. Okay. Yes. Why? Because when you increase the temperature, you're increasing the number of particles which have sufficient energy, but the activation energy does not change. It will remain the same way. The minimum energy required for the reaction to start remains the same. But what you do is you just boost the other particles so that they can reach that activation energy. So the activation energy remains the same. So it could be A or D. The number of effective collision per unit time increase definitely. Here this is wrong, so this makes this one to be out. So these ones are out already, so we can't talk about them. So the correct answer, the most correct answer is the most correct answer here is what? Is A. Then the next question is asking the next question. Each of the reaction represented below is at equilibrium in a closed container. In which of the reaction will increase in a pressure? In which of the reaction will increase in pressure? Which of the reaction increase in pressure favor the formation of product? Favors the formation of the product. So in this case, increase in pressure means that you're decreasing the volume. So it will favor the reaction which will have minimum amount of moles. Yes, meaning that if you have 4 versus 2, it will favor the one which has 2 because you have increased the pressure, you are decreasing the volume. So in this case, we have to look at what this is 1 mole, then this is 2 moles. So it can't form that. This is 1 mole, this is 2 plus, this is 3, this is 2, this is 1, this is 1, this is 2. So you see it's the same trend. This is check, this is 4, and then this is 2. So it shows that it will be increasing in that direction. This is 2, and then also this is 2. So this is equal. So basically, because they say that will increase the pressure, favor the formation of products. So because it's small volume, small number of moles from big number of moles or large number of moles, whatever. So it gives you C to be the most correct answer. Then you go to number C. Number 7, container have A and B is illustrated below. So in this case, you have to look at 20 cubic centimeter of sodium hydroxide. Solution in the beaker is added to a solution of sodium hydroxide solution in beaker 2, which of the following represents the correct calculation for the new concentration of sodium ions. They are looking for sodium ions in beaker. So in this case, what you need to look at, don't forget that they are saying that they're not saying that all of it is going in there. No, what they are saying that is only 20 cubic centimeter is being added. Yes, meaning that you have to find the number of moles which are found in here in 20 cubic centimeters. So in this case, they're also saying that. So basically, when you add this to this, you find out you have 170 cubic centimeters, and then it means that if you put it in decimeter cubed, you find out you have 0.17. So it means that if you don't have 0.17, so this one becomes wrong. So basically, the most correct answer becomes A. So that becomes the most correct answer. Then 1.8, when the galvanic cell delivers current, the purpose of salt bridge is to what is the function of the salt bridge? If you check in our distinction material for was clearly it is clearly indicated there that the function of the salt bridge is to bring about electrical neurality. Why? Because this one requires some bit of explanation. But why is because you find out the positive charge and the negative charge. The one which is positive will be receiving will be giving out electrons to this side, and then the oxidation will take place there, and then you will find out that it will become, the positive charge, for example, positive charge and negative charge. The positive charge you receive the negative one, and then the negative one will be receiving the positive one. So meaning that the negativity is going to keep on decreasing, and then the positivity is also going to keep on decreasing. So what is the function of the salt bridge? Is to bring back the ions. For example, the potassium ion will come, which are positive, will come to the positive charge, and then nitrate will go to the negative charge, so that it keeps this continuous. So it means that it brings about this reaction to continue to go in that manner, whereby it does not stop, it continues to be spontaneous. So because these ions are being neutralized by these potassiums and then the nitrates, so it brings about the salt becomes neutral, so that so to prevent that, the cell from stopping producing energy, this salt bridge is supposed to give these ions, hence to ensure this electrical neurality in the cell, and the answer becomes more B, or B becomes the most correct answer. That one requires to watch a full video when I explain that, if you don't get it now. So just go to Thundereduc and then search for that subtopic. Which of the following metal is the strongest reducing agent? So here you have to look at which one is. When you talk about a strong reducing agent, it means that it's oxidized. So the oxidized component, it means that it is high in the reactivity series. So if you look at it here, if you check here, you'll find out that the one which is, you have zinc, aluminium. So you come here and then you check it. You look at it, lithium on top. So you'll find out that the one which is on top, if the one which is on top, if lithium is here, so you see that as you go up, you're increasing the strength of the, not that one, this one. Yes, you're increasing the reducing ability or reducing agent, meaning that as you go up, if you are, there is one which is up, becomes more oxidizing agent, and then down becomes becomes more reducing agent because it is oxidized, and then down one it becomes more oxidizing agent because it is reduced. So when you come back to the question, you will find out that the question is saying, yes, the question is saying that which one of the metal is the strongest reducing agent. So in this case, when you go to the reactivity series, you'll find out that aluminium is above all. Yes, aluminium is above all of them, meaning that aluminium is going to be the answer in this regard. It can reduce all of them. It can reduce silver, zinc, copper. So it means that aluminum is a strong reducing agent. For it is oxidized. Then we go to the next question. The gaseous chloride used to disinfect water in public swimming pool reacts with the water according to the following balanced equation. The addition of chlorine gas, the pH of water in the swimming pool. Which of the following? So basically, you have chlorine plus hydrochloric acid give you hypochlorous plus hydrochloric acid. So they're asking you the addition of chlorine gas, the pH of the water in the swimming pool. Which of the following substance must be added to the public swimming pool periodically to increase the pH? Meaning that to reduce the acidity of this. So when you say increase the pH, it means that you are trying to increase the alkalinity of that substance. So in this regard, it can't be this, it can't be this, it can't be this, it must be this. Why? Because when sodium carbonate reacts with any acid, it could be the hypochlorous or this, it is gonna reduce this. How does it gonna reduce this? It's gonna reduce this by giving sodium the salt, maybe sodium chloride, whatever, and then plus carbon dioxide plus H2O. So it makes it a little bit neutral, and then the pH starts to increase. So B becomes the most correct answer. Why is A wrong? Because the salt bridge is complete the circuit. Yes, yeah, it's one saying that why is A wrong? Because the salt bridge completes the circuit. Yes, which question was it? Don't remember that. Okay, let me just explain. In most cases, when a voltaic cell delivers current, check. It means that it's already delivering the current. They're asking you, yes, it's already delivering the what? The current. You see, the reason why A is wrong is you're saying that it completes the circuit, but they are saying that it's already delivering, meaning that the circuit is already complete. You see, the answer could be correct, but what is the most correct answer? Yes, this statement makes it because they're saying that when a galvanic cell delivers current, the purpose of the salt bridge, meaning that the current is already, the circuit is already complete. Then, if the current is already complete, what is the function of the salt bridge? That's why B became the most correct answer. I think you have got it right. So please don't rush. Don't rush when it comes to questions. Why? Because in most cases there are some questions which are hidden. It requires you to at least to think twice before you get the most correct answer. So let's look at the organic very fast. We talked about this before even the paper. Consider organic compound A. You okay? Is it a primary or secondary or tertiary alcohol? Give a reason for your answer. A, look at this carbon atom with the OH group. It has 3 carbon atoms which are attached to it. Hence, it becomes a tertiary alcohol. Sorry. Then they're saying that write down give a reason for your answer. Here you can say that the carbon atom to which the functional group or which has the hydroxyl group is bonded to 3 other carbon atoms. Is bonded to 3 other carbon atoms. Yes, so that becomes the most correct answer. Then they are saying that write down the IUPAC name of the above compound. They want you to write the IUPAC name of this compound. So what are you going to write here when it comes to this? Saying that, so you have to look at the longest chain. So in this case, what is the longest chain? The longest chain is 1, 2, 3, 4. 1, 2, 3, 4. So 4 becomes butane. Remember I told you that you write up to there. The side, so it means that this becomes the side group. So it becomes 1, 2. So it is on carbon atom number 2. Or because if I count from this side, it's on carbon atom number 3. 1, 2, 3. So I'm gonna go with that. And then now I have to keep the direction. So 2 all. I have a methyl. So I have methyl. It's meth because the side group becomes methyl, and then it is on carbon atom number what? It's on carbon atom number 2. So it's gonna become 2-methyl butane 2 all. So that becomes the most correct answer. So in most cases, we mark you for the method and we mark you for the parent chain. Then they're saying that the above mentioned compound undergo elimination reaction. Write down the structure formula of the above product. The above reaction, above mentioned compound undergoes elimination reaction. Write down the structure formula of the major product. When this when this undergoes elimination method. So what is going to happen here is going to use what called the mechanical flow. So this OH is going to be lost. So the compound which is going to, not the compound, the atoms which are going to be involved is this carbon atom and this carbon atom. Why not this carbon atom? Because here I have only one carbon atom, while this one has two carbon atoms. So the inductive effect, okay, we don't study inductive effect here, but the force from this side is going to be greater. Therefore, it is this carbon atom which is going to be involved. Therefore, it's going to lose a carbon, a hydrogen, and then loses this so that it forms water at the end. And then this one, since they say the structure formula, therefore, is going to be C, two of them, then it's a double bond, and then this. So basically, it's going to look like that. So the number of 1, 2, 3, 4. So these are hydrogens. So the double bond is introduced here. This is what I'm saying, that it's going to be like that. So this one I've just drawn it down, but it's the same thing. And then this one is this. So basically, the compound is going to be like this with the hydrogen throughout. If you don't put your hydrogens, you're going to lose it. You might only get the one for the functional group. Yes. So the next question, they are saying that as above mentioned, okay, we are done there. Compound, consider the organic molecule B. When you talk about organic molecule B, which one is yes? Pentan 3-on. Okay, how about it? They are saying that consider, okay, we have considered it, define functional isomer. Whenever you talk about functional isomer, isomers, they have the same definition, but what they have stated there is what changes. Organic compounds with the same molecular formula. That is, whenever they ask you about what is isomer, whatever isomer they have asked you, it's the same thing. Organic compounds with the same molecular formula. If they say position isomer, but different position of organic molecules, functional isomer, organic molecules the same molecular formula, but different functional groups. So like that. Structure or chain isomer, so it's the same thing. So in this case, because they're asking about functional isomer, is organic molecules the same molecular formula, but different functional groups. So that's how you're supposed to define that question. Then they're saying that the homologous series to which the above mentioned compound belong. To which homologous series? Homologous series to which the above mentioned compound belong. Compound B. So compound B, it is a keton. So it belongs to ketones. Then they are saying that IUPAC name of the functional isomer. If it is pentan 3-on, then the functional isomer is going to be an aldehyde, which is pentanal. Simple. The letter that represents its positional isomer, meaning that when you talk about its positional isomer, so we have to look at it. Must be of the same culture. It must be the same keton, because they're saying positional isomer. So 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. It's 5, and then this one also 5. This is the carboxylic acid. This is ester. Yeah. So it becomes E, because it's the same thing as a keton, but in this case it is pentan 2-on, and then this one is pentan 3-on. So that it means that one becomes the most correct answer. That's yes. So we have got it. Write down the balanced equation for molecular formula of the complete combustion. Whenever they ask you about combustion of anything, the product I told you that is always carbon dioxide and water. And then the only challenge where it comes from is when they ask you to balance. Obviously, you have to balance, but they're saying compound E. Compound E. So it means that how many carbon atoms is 1, 2, 3, 4, 5. So I'm gonna come here and I say there are 5 C, 5. How many hydrogens? 3 plus 2. That's 5 plus 2. That's 7 plus 2. That's 3, 5. Did I say E? Let me check. Oh, F. Sorry guys, it's in F. Okay, is 3 plus 2 times 3. You see, this is 6 plus 9, 12. Hydrogen is 12. Carbon is 1 plus 3, which is 1, 2 plus 3, which is 5. So it's meant the same thing. So basically it's like that. When they said combustion plus oxygen, yes. So that's the first, that's the reactant. And then the product is obviously is going to be carbon dioxide plus H2O, of which 6, 5, it was supposed to be 8 there, and well, yeah, and then it's balanced. So combustion, always this is the product. You understand? Yes. So we come, we give you for writing the correct symbols, we give you for writing the reactant is basically correct, and then balancing it, obviously balancing is gonna get 1 mark in that regard. So yeah, that's how we were supposed to write this and get those 3 marks. Let's go to question 3. What are they saying on question 3? Is there anyone who has a question? Someone is saying that I'm not sure. I want 1.2 in the multiple question. Choose alcohol. I try to explain that. F not E. F not E. 1.2. Okay, I'll go back there maybe when I'm done with this, and then I don't understand what you're saying. F not E. If not E. Metric Mokatu. Please try to elaborate on your question. Okay, let's go to the next question, and then they are saying that the structure formula, the structure isomer with the molecular formula, this are used to investigate the effect of branching on the physical properties of hydrocarbons. So here we are talking about the branching. Don't forget that we have 3 things when you talk about the properties. We have the boiling point, melting point, and then boiling point, melting point, and then vapor pressure. Vapor pressure increase as the branching increase. Melting point decrease as the branching decrease. The boiling point decrease as the branching increase. Yes, you have to know that principle so that at least you are able to understand all the questions. They're saying the results obtained for the first 2 investigations are shown in the table below. Here, a little bit straight, more branched. How many branches are these? Yes, and then here, 1, 2, 3, 4. 1, 2, 3, 4. Okay, more branches. All right, let's go to the question. They're saying that define boiling point. Boiling point is the point at which the temperature of is the boiling point is the temperature at which the solid and the liquid phases of the substance are at equilibrium. That's what called the melting point. The solid and the liquid are at equilibrium. Their phases must be at equilibrium, meaning that what goes to the solid is equal to what goes to the liquid. But don't forget that in this case, this is all or nothing law, as I explained that. It's a definition. you don't give all the points, you get 0. We don't have here trying, no. Write the independent variable in this investigation. What do you think is the independent variable in this investigation? If you look at it, basically the boiling point, the melting point, or the boiling point or melting point, one of the two, will depend on this ABC. But how about them? It's the same compound. So it means that how branch it is, the length of, it could be the length of the chain or the branching. And this branching is going to result in the surface area. How big is the surface area? Yes. So the answer could be the branching, or it could be the chain length, or it could be the surface area. So whatever you give, it could be correct. Then they're saying that explain why the 3 organic compounds are called structural isomers. Why are they structural isomers? So we say that what are isomers? Isomers are molecules with the same molecular formula, isn't it? We talked about it. Yes. But they are saying structure, meaning that what is changing is the structure. Simple. But different structure formula. They have the same molecular formula. But the structure, how the atoms are arranged in space or in vicinity, is different. But everything is the same. Only the arrangement of the atoms. Therefore, they are isomers. If you count the number of carbons, they are the same. Count the number of hydrogens, are what? Are the same. Hence, they are structural isomers. They are saying that. Explain why. Okay, I'm done. Write down 3.4. Write down the 3 types of Write down the type of intermolecular forces present between the atoms. Don't forget that all these are alkanes. The moment the alkanes, then the type of intermolecular forces of attraction, alkenes, and the alkynes, the type of intermolecular force of attraction is London forces. So we only talk about London forces. Yes. And then they're saying that explain the difference in the melting point between A and B, between molecule A and B. So what are you going to talk about? The melting point. They're saying explain the difference in the melting point between A and B. If you look at A, the melting point is negative 154, and then B is 29, meaning that, yes, in this case, the melting point as what are you going to talk about? So let's go to molecules, and they said A and B. So if you look at A, the more it's branched, the more it becomes spherical. You understand? So in this case, this one and this one. So this one is more spherical than this. So you can say that this one is less spherical, and then this one is more spherical. Since this one is less spherical, therefore it has weaker intermolecular forces of attraction in that regard, and then this one has strong intermolecular forces of attraction. And since it has weak intermolecular forces of attraction in terms of this melting point, therefore it's going to have a lower melting point. Well, this one has, because of its spherical nature, it is going to have require more energy to break it. Therefore, it's going to have a higher melting point. But when you say it has a higher melting point, because you're comparing the two, then it means that the higher melting point is big compared to this, not comparing to this. So you're comparing to that. So basically, less spherical, more spherical. Okay. Then this one, since it's less spherical, it means that weak intermolecular forces of attraction, more intermolecular forces of strong intermolecular forces of attraction, less boiling point, more boiling point. That's why you see it in that regard like that. This is more negative, and then this is more positive. Yes. As I say that, as for the case of the melting point, the more branches, the the when it, the branching is happening, it means that you're gonna have strong intermolecular forces of what? Strong intermolecular forces of attraction. So the melting point becomes more positive than more negative. Yes. And it is the reverse for the boiling point. Then they're saying that explain why the three compounds are called this. Okay, we're done with that. Okay, we're done with that also. Then they're saying the investigation 3, the vapor pressure is measured in millimeters of mercury at 25 degrees C. Okay. Use the information in investigation 2 and then match the correct vapor pressure of this. So you're going to look at which one has the higher boiling point is going to have the lower vapor pressure, as I explained before I said this question. And then explain fully, explain your answer fully. So in this case, we are going to say that we come here and then we look at it here. Which one has a higher boiling point? This one has a higher boiling point, so it's going to have the lowest vapor pressure, lowest. So A must be the lowest. Then this one is next, it's going to be the next, and then this one is going to be the last. So A, it must have the lowest boiling point. Let's go to the lowest boiling point. Sorry, vapor pressure. So it's going to be A, you see? And then followed by B is supposed to be, then this one is going to be B because it has the second last vapor pressure. And then this one has the highest vapor pressure because it has the lowest boiling point. So it's going to be, C. Yes. So basically it's supposed to be like that. Explain your answer. The boiling point of A is higher than that of B. Therefore, the higher the boiling point, the lower the vapor pressure. Basically, we say that the boiling point of A is higher than that of B when you looked at it. And then we say that the higher the boiling point, the lower the vapor pressure. You understand? Yes. Or in the reverse. You can write it in the reverse way depending on, you can say that A has B has a higher boiling, a lower boiling point than A. Therefore, the lower the boiling point, the higher the vapor pressure. You see, so you can write in a reverse way or in a positive way. Still, we will give you a mark, but these principles, they apply depending on the what? On the subject. Yes, you might think that it is going to apply even in another subject. It might not be the same. Then we go to the next question. The next question, what are they saying about the next question? Next question, they're saying that the following diagram, the flow diagram below shows ethene can be used to prepare the various compounds A to F presented. Okay. Identify B. What is B? Identify the type of reaction represented by B. B is from here to here. So that's elimination method. Or what are you removing? You are removing the water there. Therefore, it is dehydration. So A is away. Then they're saying that B from here to here, from a haloalkane to an alkyl. So you are substituting. So it becomes substitution or hydrolysis. You can use hydrolysis. Why? Because water must be there in that reaction. Write down two reaction conditions for B. When talk about B, where is B? From this to this, what are the two because you are dehydrating, so whenever you talk about dehydration, you must have concentrated sulfuric acid and then some bit of heat. So heat is sometimes use concentrated sulfuric acid or concentrated phosphoric acid. It could be sulfuric acid like that or phosphoric acid, depends on what you wanted to write. Then they are saying that the chemical formula of the catalyst needed. What is the chemical formula? 3.4.2. No, man. They're saying that write down the reaction. Oh, two conditions you're done that. For reaction A, all right, write down the name of inorganic reactant. Inorganic reactant, the moment you are forming alkene to alcohol, you have to use H2O. Water must be present. And then they're saying that catalyst, chemical formula of the catalyst. Chemical formula of the catalyst. Yes, it's the same acids which you can use, because sometimes you call it acidified water. So you acidify the water there, and then yes. They are saying that reaction structure formula, write down the balanced chemical equation. Balanced chemical equation for the structure formula of reaction C. When you come back here, you look at reaction C. Where is reaction C? From here to here. So it means that here you just have to write. Right here, just have to write from here to here. They say C. They said from here to here. So this one is acting without, because they said ethene to bromoethane, meaning that I'm gonna have a bromine there and a bromine there, and then a hydrogen. So meaning that I'm gonna put did I say bromo, not dibromo? So it means that what I'm going to use, I'm gonna put a hydrogen here, and then I'm gonna hydrogen bromide. Yes, if it was dibromo, then it would have been bromine only. Yes, so basically you put hydrogen, you put hydrogen, you put hydrogen, you put hydrogen. That's what they are talking about. We give you a mark there, we give you a mark there, we give you a mark there. And then they're saying that chemical formula of the catalyst. So we are done with that. Structure formula. Explain why no water is needed. Basically, you don't add water so that you avoid the formation of the alcohol or the hydroxyl group. That's why there is no water which is added in that reaction. The moment you add water there, then it's going to form alcohol. Reaction E represents the conversion of alcohol into inorganic compound X. Okay? Formation of alcohol into an inorganic compound X. Reaction E. So it means that this E, because you have alcohol, you have a carboxylic acid, so E, it becomes an ester. So how many? 1, 2, 3. So it's 3 carbon atoms. Ne? Is it 3? No. It's 1 plus this. So it's 4, 5. So there are 5 carbon atoms. And then here is 1, 2. So it's going to be ethyl propanoate, because 5 pentanoate. If this compound is going to become ethyl pentanoate. Okay, let's go to the question and see what are they saying. The type of reaction, esterification, we know that. I talked about it even. The catalyst used sulfuric acid. I told you, whenever I talk about esterification, it's sulfuric acid. Structure formula of compound X, you see? Even I saw the IUPAC name of compound X. Structure formula of compound X is the same thing here. Structure formula of compound X. Yeah, I said ethyl, because this is 1, 2 is ethyl, and then this 1, this is 3, so it's 4 plus 1, it becomes 5. Pentanoate, ethyl pentanoate. So you write the structure formula, of which structure formula, they said structure formula. That's the alcohol. Remember, the alcohol gives us one oxygen, and then another oxygen comes. This one comes from there, and then sorry, they said the structure formula. Yes, so you put the 5 carbons, 1, 2, 3, 4, 5, and then you put the hydrogens throughout. So basically, that's what they wanted. Ether, pentanoate. Then, yes, I think I'm done with that. I think compound F takes place in presence of warm water. And then the concentrated sodium hydroxide, use the condensed structure formula, write down the balanced equation for the reaction. So in this case, what are they looking at? They're saying compound F. Compound F, where is compound F? They're saying compound F, where is compound F? Yeah, compound F. Oh, reaction F. So basically, what are they looking at? They are looking at for you to write the balanced equation. The balanced equation, how are you going to write it? From here to here, meaning that's just a reverse. So in this case, you just add sodium hydroxide. Add sodium hydroxide, and then the bromine is gonna replace. It's gonna replace. Sorry, it's gonna not to replace. It's gonna remove sodium bromide, and then water from here, and then 2 hydrogens are being lost. This is what I'm saying. Ethyl brom. It said bromo ethane. Then add the sodium hydroxide. Then you're gonna form this, which is ethane. Yes, plus what? Plus now, this is gonna react with the bromine from sodium bromide. But what about this hydrogen? This hydrogen is gonna react with another hydrogen here, so that now from here another hydrogen from here, so that it becomes 2, so that you form this. So plus H2O. You get a mark, you get a mark, you get a mark, you get a mark, something like that. So that's what you're supposed to get from that reaction. Then the next question. Question was 3.7. 3.7. Saying that large straight chains, alkane can be catalytically cracked to produce short chains. We call it cracking. Yes. Alkanes and then branch alkanes, okay, which are more suitable for use in petrol. The reaction below indicates the catalytic cracking of octane. Octane is 8. So meaning that when you do 8, so what happens? You break it into smaller pieces. So write down the IUPAC name of Y. What is Y? Now I don't know, but this was 8 of them, but I have 2 of them I've removed them. Then definitely this one is gonna be hexane. Why am I saying hexane? Because it was 8. 1, 2, 3, 4, 5, 6, 7, 8. So I removed the 2. So what I'm remaining with is gonna be hexane. Remember, all these are hydrocarbons, so it's gonna be hexane. So what is? I think I'm done with that. Briefly explain why short chain alkanes are branched and branched chain alkanes are more suitable for use in petrol than straight chain alkanes. Why? Why are they more suitable? They are more suitable because short chain alkanes they have they are more suitable because they have a lower boiling point. So the intermolecular forces of attractions are less. Therefore, they have a lower boiling point. Therefore, they are more flammable. They are flammable, so they can burn easily to produce energy. You understand? Yes, that's why they are used like that. Oh, we are going to the next question. So it means that those people who manage to get all those marks, you are able at least to see that the paper was not that difficult. Let's go to the next section where it involves calculations, and then we see. If you have a question, let me know. If you have a question, let me know. All right, let's go to this question. The following apparatus is used by the group of learners in investigation to find out how the surface area affects the rate of reaction. Yes, how the surface area affects the rate of reaction. They're saying between excess, this word is very important, excess sodium, excess solid of magnesium ribbon with the rich nitric acid. Yes, meaning that sodium, this one is in excess. Magnesium ribbon is in excess. It can't be a limiting factor. So we get it from downward displacement of water, or what you call, yes, upward derival. So one of the two methods is the same thing, or if they ask you the method. During the reaction, the gas formed is collected in the measuring cylinder. The balanced equation for the reaction is, here is the balanced equation, meaning that this was in excess, they said it. So you need to know that excess. All right, let's start. So they're saying that in experiment 1, they plotted, okay, below. What is the question? Beside the mass and volume of the experiment, give one other variable that must be kept constant. Did they talk about heat? No. So maybe temperature. Temperature must be what? Must be kept constant. Did they talk about the concentration? Concentration must be kept constant. Concentration must be kept constant. Then question 2, they're saying that write down the independent variable. Write down the independent variable. Write down the dependent variable. What depends? What depends? What depends? The rate of reaction, or the volume of the gas you have collected will depend on the concentrations, maybe depending on, yes. So basically the volume of the gas per unit time you have collected is dependent. So that's why it is on this. And then they're saying that use the graph to calculate the average rate. Use the graph to calculate the average rate of reaction, 2.2, between 2 and the average rate. Okay, now let's go. 2 minutes. So 1 minute is 60. 2 minutes is 120. So I have to look for 120. So 120 is around here. Isn't it? Yes. Because each let me look at the original paper. I hope you have the paper there with you. Oh, so if you look at this, each small box, it was let me see, it was 10. So meaning that 120 is its first box, second box is there, and then 2.5, so it means that you have to add 120, 130, 140, 150. So it's 150. So meaning that you have to do here. Yes. So when I do it, it's around the final is around 48, and the initial is around 42. So I'm gonna say, don't forget that the rate is change in the volume or concentration of the product divided by the change in time. So rate is gonna be equal to change in the volume over change in time, whereby the volume is equal to gonna be 48 minus 42 divided by, I started it from 120 to 150, and then when I divide, you end up having 0.2 centimeters per second. You understand? Centimeters cubed, ne? Because this is measured in cubed. Centimeters cubed per second. Yeah, so that was supposed to be the answer. Then we go to the next question. What is the next question? Okay, they're saying that will the rate of reaction be at 250 greater or equal to or less than at 250? If you look at it, the graph is 250. Is approaching constant or equilibrium completion. Do you think it's gonna be greater than, equal to, or less than? However much the graph is still going, there is an increase, but the increase is not as that fast as this. So it's gonna be less than. The rate, they're talking about the rate. They're not asking you about the increase. They're asking you about the rate. So they will be, we call it increase on a decreasing rate. The increase is there, but not that as faster as it was before. So that is, that's the meaning. So it's gonna be less than. Why? Because the steep or the gradient is less than at 120. The steep at 250, if you look at it here, the steep here is not as that great as at 120, you see. So the increase there, but not that much. Therefore, the answer is going to be less than. Then we go to the next question. What are they saying about the next question? The next question, they are saying that will the rate, okay, then predict how the gradient of the graph for the experiment 2 compared to experiment 1, right? Increase, decrease, or remain the same? Experiment 1. Yeah, look at the division, the state. This one is cut is small. Definitely, this one is one large piece. So it's the reaction, the graph is gonna be less than, or it's gonna be decreased. It's not that. If you look at even the slope, if they asked you to redraw, it would have been like that maybe. You understand? So the rate is too slow, so it's gonna be decreased. And then they're saying that calculate the mass of the magnesium that remained in the conical flask when the reaction has stopped. Assume that the molar mass is 24 decimeter cubed. So the moment you have the mass, so what is the, in this case you have the volume and then you have the molar volume. Yes, you have the volume and then you have the molar volume. Therefore now you can find the number of moles. Yes, you can find the number of moles since you have the volume and then you have the molar volume. So how are you going to get the volume? They said it here. Yeah, they say that in the following year you find out the surface area of this diluted in nitric acid. And then they come here, they say that calculate the mass of magnesium. Yes. So the first thing you need to do is to calculate the mass of magnesium metal. Yes. That remains in the conical flask when the reaction has stopped. assume that the molar volume of this is this. All right, now you come here and then you look for the volume. So if you look at it here, the volume is 60. Let me just clean up here so that I use here. So first of all, you need to find out the number of moles. How are you going to find the number of moles? Number of moles is equal to volume over molar volume, of which molar volume is 24 decimeter cubed. And then the volume here is 60. But this is decimeter cubed, while this is cubic centimeter. So I have to convert 60 into decimeter cubed. So 60 divided by 1000, so it gives me 0.06. So I'm going to say that number of moles is equal to 0.06 divided by 24. So number of moles is going to be equal to, so you calculate 2.5 times 10 power negative 3. So those are the number of moles. So since I've got the number of moles, so number of moles, this is the number of moles of the gas produced. So now I can compare that the gas produced, which is hydrogen, number of moles of magnesium compared to the number of moles of hydrogen, yes, is molar ratio is 1 to 1. How do I get molar ratio 1 to 1? Is from the equation. Magnesium to hydrogen is 1 to 1. So if I have 0.25 moles of hydrogen, how many of magnesium I'm going to have? Is the same thing. So it means that number of moles, therefore number of moles of magnesium is going to be equal to 2.5 times 10 power negative 3. You understand? So, but they are looking at the mass. So how do I get the mass? Don't forget that number of moles is equal to mass over molar mass. So I have the number of moles. Yes. I have the mass. Do I have the mass? No. Do I have the molar mass? Yes. I go to the periodic table. On the periodic table, it was found out that it is what? Periodic table, magnesium is 24. Yes, magnesium is 24. So it means that to find the mass is going to be mass, molar mass times number of moles. So it means that I'm going to multiply here by 24. So the number of mass is going to be equal to 0.066 grams. So those are the number of moles. So the mass magnesium used, isn't it? But the question is asking, what is the question asked? Assume that calculate the mass of magnesium that remained. You understand? That magnesium that remained, this is the mass of magnesium which was used. You understand? So they want to know how much magnesium remained. If you come here, we started with, because they said that it was in excess, we started with the 2. So it means that what I used, when you subtract it, so therefore I'm gonna say that the magnesium used is gonna be 2 minus 0.06 grams. So it gives me 1.94 grams of magnesium. So this is a 1.49 grams of magnesium was left. Class, are we together? Are we together? Yes, let me know, eh? Let me know if you have any question. Yeah, as I'm here to help you out. All right, let's go. I might go for a short break, but I'll let you know when that short break is coming, maybe for 5-10 minutes, né? Yeah, so that I can have something to drink, né? I come back when I'm more energetic. Yes, let's go to the next question. Let me finish this question, and then maybe I can go for a short break. Then they are saying that medication used to relieve headaches is available as a powder and or a tablet. Use the collision theory to explain why the powder are more faster than. Basically, when you have a powder one, it increases the rate of reaction. That's why you see here the one which was a pellet, not cut, the rate of reaction was slower. Check here, it was faster than this. Why? Because this one, the other components are not easy to find. The surface area is small. So in this case, powder have a large surface area than solids ones. Therefore, more effective collision per unit time. Whenever I talk about effective collision, guys, you must always talk about per unit time. So you hear what you can say that powder has a large surface area or increased surface area or site of contact, whatever, than solid tablets, and then this increases more effective collision per unit time. Yeah, that's how the question was supposed to be answered. Yes. Let's go to the next question. Guys, I'm going to come back at exactly 10. Yes, I'm going to come back at exactly 10 so that I finish up the remaining. Someone is saying that I'm not sure. The concentration we are given was 1 for nitric acid, not hydrogen. The ratio is this to this. Okay, before I go, guys, let me check his question. The concentration given was where okay, let me check what you are saying. Oh, you're saying that how the surface area dilute nitric acid concentration. Yes, the concentration given was for nitric acid. True. Yeah, but not hydrogen. I did not use this concentration. I did not use it. What I used because here they say that this is a gas, and then this graph is showing you gas. Don't forget that I said number of moles equal to volume over molar volume. You understand? And then when I was here, they said that volume of the gas produced, and the only gas here is the hydrogen. I used this graph too. In this my calculation, I did not use that concentration because yes, what you say that it is nitric acid. However, I did not try to do the calculations concerning passing through there to see if I can get the answer. But if you got the same answer, then automatically they will award you your marks. Ne? Yes. I think I'm clear there. Oh, my brother, you got it right. So, guys, I'm going to break off for some 10 minutes. Then I'm going to come back after 10 minutes. Meaning that that time I will be back. I'm back so that we can start from where we stopped. We're supposed to go to chemical equilibrium. Yeah, as I said that I will be back. So now I'm back again so that we can discuss chemical equilibrium and then acids and bases, and then we go to all right. Let's go to question for chemical equilibrium, and then we'll see what do they want in this question? What do they want in this question? So we finished this question. Let's get to finished. Yes. Let's go to this question for chemical equilibrium, and then we discuss it. Just a moment. What are they saying in this question? They say that hydrogen is prepared in a reaction by the reaction of methane and steam. So it means that here you are trying to heat water so that it forms steam. So that's the meaning. So they're saying that the first question, they're saying that, okay, hydrogen plus steam, because it's in a gaseous form, plus carbon monoxide gives you this. And then enthalpy change is positive, which means that the reaction is endothermic. So the methane and steam are sealed in 2 decimeter cubic container to react and allow the to reach equilibrium at temperature T. So they have not specified which temperature. They just say the temperature T. Use state reference principle. So here they are talking about what you need to talk about. You need to talk about the closed system. You need to talk about new equilibrium, and then you talk about oppose the disturbance. Yes. So don't forget that it's also all or nothing law, meaning that either you get all the marks or you lose all the marks. So when equilibrium is in a closed system is disturbed, when equilibrium in a closed system is disturbed, the system will reinstate new equilibrium by favoring the reaction that will oppose the disturbance. That's it. When the equilibrium in a closed system is disturbed, when you disturb the equilibrium, okay, what happens? They're saying that the system will reinstate the new equilibrium by favoring the reaction that oppose the disturbance. That's what you're supposed to talk about when it comes to that. So then the next question, they're saying that use the reactions principle to explain how the changes in will affect the yield of hydrogen. Number 1, adding methane. So when you add the methane, it means that you're increasing the concentration, the number of particles which are reacting, meaning that you're going to have the equilibrium is disturbed, and then it's going to favor the forward reaction, and more products are going to be formed. So adding methane will increase the concentration of methane. The forward reaction is going to be favored. The yield of hydrogen is going to increase. The forward reaction is going to be favored, and the yield of ammonia, hydrogen is going to be increased. So basically, that's how you're supposed to write. And then what happens when you decrease the volume of the container? So you have to look at how many number of moles this side and the other side. Let's count. You have 1 mole here, 1 plus 1, and then you have 1 plus 3. Here you have 4, here you have 2. So when you decrease the volume, it means that you're favoring the reaction which result in fewer number of moles. Remember, when you decrease volume, you are increasing the pressure. So the reverse reaction is going to be favored, and then it means that the number of hydrogen formed is going to decrease. So increasing the pressure, they will favor the reaction that produce less number of moles, and then the reverse reaction is going to be favored. The yield of hydrogen is going to decrease. So that's how you're supposed to say. Increase in pressure favors the reaction that produce less number of moles, and then the reverse reaction is going to be favored, and then the yield of hydrogen is going to what? It's going to decrease. That's what you're supposed to talk about. What about the graph? I brought the same graph, similar graph, before you wrote your paper, and then let's look at it. And then I said that this was the simplest graph they have ever brought when I was explaining that, and it definitely is the same graph which came. They're saying that the sketch graph below shows the change in the number of moles of methane at the steam and the carbon monoxide as reaction proceed for the preparation of hydrogen gas in 2 decimeter cubed of the container. All right, write down the reason why there is no number of moles of each of gas between T1 and T2. Write down why there is no change in the number of moles of gas between T1 and T2. T1 and T2, it means that now the reaction has reached what? Equilibrium. The reaction is in the chemical reaction is in the dynamic equilibrium. That's meaning that the rate of forward reaction and the reverse reaction are equal. Yeah, that's why you see there is no change in the number of moles. This information in the graph calculates the equilibrium constant Kc for this reaction, of which first identified, they give you the volume. Yes, they gave you the volume. Volume is equal to 2 decimeter cubed. So since I have that, guys, if you have a question, let me know. As I'm back. Yes, they're saying that what are you supposed to say here? You can use the rice method, as I said yesterday. I added the other one to show the concentration. And then now, should I use, how many are they? Let me just use a blank page so that you get it right. Rice method. Yes. So now, which compounds do we have? Components we have. We have to first identify here something. All of them are gases. So I have methane. React with steam. And that is a reactant to produce carbon monoxide and hydrogen. Carbon monoxide and then hydrogen gas. Meaning that these are products, these are reactants. But what is the ratio of this? Methane is 1113, meaning that I have 1113. So the initial amount, obviously, based on this graph, you'll see that these two, the product is starting from 0. Therefore, I'm going to put 0 and 0. And then, what about these ones? We don't know. We don't know. Do we know? Hey, we know. Yes. This one started from 1.4, even this one 1.2. 1.4 is methane. Yeah, this one is 1.4 and 1.2. Yes. At equilibrium, definitely, what is being produced at equilibrium? In this case, carbon dioxide is what 0.6, 0.6. Carbon monoxide 0.6. Is it carbon monoxide? Let me check. Yes, 0.6. But now, this one, if it is 0.6, so 0.6 times 3 is 1.8. So it means that 0.6 times 3, because these are 3 moles. Yeah? And then what about this? In terms of moles, graph for this one is going to be is 0.6, 0.6. Isn't it? Yeah. 0.6, 0.6. Yeah. Then now, when you subtract to get what remains at equilibrium, is going to be 0.6 minus 1.4, which gives me 0.8. Let me just do like this. 0.8. And then here, when I subtract this from here, it'll be 0.6. And then this one is the same at equilibrium and 1.8. Now I need to find out the concentration, because we saw that the volume is this. So I'm gonna say 0.8 divided by 2. So it gives me 0.4. 0.6 divided by 2 gives me 0.3. 0.6 divided by 2, 0.3. 1.8 divided by 2 gives me 0.9. You see? Yes. Then from there, I use the Kc. Kc is equal to, we saw that products, which is carbon monoxide, to hydrogen. Hydrogen, we saw that, sorry. There are 3 of them, number of moles, and then you have methane, and then you have steam. Yeah, you have steam. Yeah, from this expression, you can find now Kc is equal to carbon monoxide 0.4 times carbon monoxide. Carbon monoxide is what? Let me check. Oh, carbon monoxide is 0.3. 0.3. 0.3 times 0.9 cubed over 0.4 times 0.3. So the Kc value becomes 0.8. 0.82. 0.8. 0.82. Yes. 0.82. Yeah, basically that's how you're supposed to calculate for this case. In this case, the case was not that difficult to identify, because the graph was showing you everything which is required, and then that's marked to be one of the simplest cases I've ever seen. Yes. Anyway, if you get it, let's hope that you're gonna get it on the final, because we'll bring still the case for you to calculate. Let's go to the next question. What's happening? Okay, let's go to the next question, and then we see. The next question, they're saying that decrease in the volume. Oh, yes, we're done with this. We finished this. So meaning that that's how you're supposed to be those. Guys, you must not lose those 7 marks. You must not lose those 7 marks. Yes. Then we go to the next question. Temperature T is decreased. How will this change affect Kc value for the above reaction, right? Increase, decrease, or remain the same. You come back and then see. Is this reaction endothermic or exothermic? We saw that it's endothermic because the enthalpy change is positive. When you decrease the temperature, obviously, the Kc value is gonna what? It's gonna decrease. You're gonna form less product. And then if you have less product, definitely it means that you have less. The value of Kc is gonna be what? It's gonna be small. Then we go to acids and bases. Acids and bases. If you have a question, let me know. Acids and bases. Let's go. They're saying that balanced equation below represents ionization of sulfuric acid. Step 1, yes. Then step 2, sulfuric acid gives you this hydrogen ion and the hydrogen sulfate, and then hydrogen sulfate, sulfuric acid should get hydrogen ions and then sulfate ions. And then is sulfuric acid a strong or weak acid? Sulfuric acid is a strong acid. Why? Because it ionizes completely. It ionizes completely when dissolved in water. Yes, sorry, it ionizes completely in water. Yes. Then write down the formula of the conjugate acid-base pair in step 2. Step 2, conjugate acid-base pair, meaning that this gives the hydrogen ions to form this, and then this gives this to form this. So this goes with that, and then this goes with that. Yes. So in this case, they're asking you to write the conjugate acid base pair in step 2. So you can either write this and this or that and that. Still, we will give you a mark. They are saying that sulfuric acid is diprotic. What is the meaning of diprotic? Diprotic means that acid which can donate 2 hydrogen ions when dissolved in water. Yes. Write down the formula of amphoteric in the above reaction. In this case, what acted as the acid and acted as a base. In this case, this is an acid. Yes, because this and this and this. You understand? Now, this sulfuric acid, in this case, it was a base. Acid, base. So it acted as a base here. And then here, when it came here, it donated the hydrogen to this. Therefore, it's the same thing here. In this case, act as a what? Act as an acid. So basically, in this equation, hydrogen sulfate is the one which acts as amphoteric. However, even water can act as amphoteric, but in this case, it didn't. Yes, it didn't. It didn't act that way. Then we go to the next question, saying that impure sample of potassium hydroxide pellets with a mass of this is added to this moles of sulfuric acid with a volume of this. It reacts according to the balanced chemical equation given below. Okay. Calculate. They're asking you to calculate the pH of the sulfuric acid. So what are you going to calculate here when it comes to the pH? pH, don't forget that pH is equal to negative log of hydrogenium ion. pH is equal to negative log of hydrogenium ion concentration, negative log. But how am I going to get this hydrogen ion concentration? Because here they say that this is in the number of moles of this. It reacts according to the equation, saying that the impure sample of hydroxide, potassium hydroxide pellets with a mass of this. Yes. With a mass of this is added to this sulfuric acid. You see? With a volume of this. So I have the number of moles and I have the what? I have the volume. So in this regard, I can find the concentration. Yes, let's find the concentration. don't forget the number of moles is equal to, let me just go direct. Concentration is equal to number of moles over volume. So do I have the number of moles? Yes. Do I have the volume? Yes. The volume is, number of moles is 0.09, isn't it? Concentration, volume is 600 divided by 1000, which gives me 0.6. So 0.6. So concentration in this case is gonna be concentration of sulfuric acid. It's gonna be when you calculate, is 0.15 moles per decimeter cubed. So that's the concentration of sulfuric acid. But now, if you look at the mole ratio of sulfuric acid to water, because you are looking for this hydrogen ions, or how many hydrogen ions are produced. So in this case, you'll find out that it's 1 to 2 sulfuric acid to H2O or hydrogenium ion. So it's 1 to 2. So if in this case I have 0.15, so these ones, for them to be 2 is gonna be 0.15 times 3 times 2, 1 times 3. So it gives me 0.3 moles per decimeter cube. So that's the concentration in that regard. So since I've got the concentration, so I'm going to apply my formula that negative pH is going to be equal to negative log of hydrogenium ion. Yes, concentration of which negative log of 0.3, and then the answer gives you 0.52, yes, as the pH. So that's how you're supposed to calculate that. Understand? Yes, that's how you're supposed to calculate that question, unless you have a serious question, but that's how you're supposed to calculate that pH. Then they're saying that the percentage purity of potassium hydroxide pellet used is 80. Calculate the number of moles of pure potassium hydroxide that reacted with the sulfuric acid. Now you need to find out, determine, they're saying that percentage purity of potassium hydroxide pellet, yes, used is 80% of the purity. Okay, calculate the number of moles of potassium hydroxide that reacted with the sulfuric acid. So it means that here I have to first identify the number of moles. The number of moles of yes, I have to first identify the number of moles which are found in 11. How am I going to find the number of moles? This is mass. Number of moles, this is mass over molar mass. So I find the number of moles. So, but this number of moles, not all of it was used. They said only 80%. So it means that, let me clean up here. It means that I'm going to use that small expression to get the number of moles, and then after that I get the percentage purity in that regard. Yes. Okay, let's start. Number of moles is equal to number of moles is equal to mass over molar mass. So which number of moles, in this case, so that the number of moles is equal to the percentage, the mass which was given. The question is 11.2 over, you have to find the molar mass of potassium hydroxide. Potassium hydroxide. This potassium hydroxide. This one is 16. This one is 40. This one the periodic table. So it's gonna be 56. Yeah, it's 39. 39? Yeah, it's 39. Not 40. It's supposed to be 39. Okay, check on the periodic table potassium. Potassium, so I'm looking for the molar mass. Potassium is 39 plus oxygen, which is 16, plus hydrogen, which is 1, which gives me 56. So it means that number of moles is equal to this divided by 56. Number of moles is going to be equal to 0.26 moles. But don't forget that all these are the number of moles which were found where? These are number of moles which were found in what? In 11 grams of potassium hydroxide. So it means that now what am I supposed to do is to equate it, or to make an expression of 80%, because they said 80%. So it means that 80% is equal to 80 divided by 100, now times 0.26, so that I know exactly how much was used. So the number of moles in this case, they're going to be equal to, when you multiply, is going to be equal to 0.16 moles. So this is what they wanted. So you have to first convert this number of moles, this one, the mass, into number of moles, and then after that they say that only 80%, you understand, was used, meaning that what is the 80% of 0.26? It is 0.16. So yeah. Then they are saying that determine which reactant is in excess, hence the final solution is acidic or basic. To get how much is the basic or is the acidic, how much is not a limiting reagent. In other words, here you have to compare the number of moles. So you have to compare the number of moles of sulfuric acid to potassium hydroxide. We saw that the potassium hydroxide is 0.16. Yes. If this is 2, then this is going to be half of it, which is 0.08. You see? Now you have to identify which one is in excess. Which one is in excess? Let's go back here. Oh, I rubbed it off. But sulfuric acid is in excess. When you subtract this from the initial amount of sulfuric acid we calculated, the number of moles of sulfuric acid, you see that sulfuric acid has more moles, meaning that sulfuric acid, the one which has more moles, you see that it's the one which is going to be in excess, meaning that the other one will be finished immediately or very fast before the second one has finished. So in this case, in this answer, compare with the calculation we did, you find out that sulfuric acid is in excess. So let's go to question number 8. This is, this question is just the cells, electrolytic cells and electrochemical cells. Yes. Question number 8. A galvanic cell is a setup used to measure, setup using manganese, manganese, and then unknown narrow x, the EMF of the measured standard conditions is this. Okay, and then the electron flow from, oh, this is very important. Electrons flow from manganese to external circuit. Okay, sharp. You say that setup, manganese unknown, sharp, is the reaction that occur in this cell spontaneous? Write down only yes or no. It's spontaneous because the voltage is positive. Yes. So yes, it is spontaneous because the EMF is greater than 0. So I said it that if the EMF is greater than 0, then it is spontaneous. Which electrode XY is a cathode? A galvanic cell. They said it's a galvanic cell. Don't forget that in a galvanic cell, you have anode, and then cathode. Anode is negative in galvanic cell. In electrolytic cell is positive, and then this is positive. In electrolytic cell is a negative. But oxidation, reduction is the same in both electrolytic and galvanic. So if it is oxidation, now we are saying that they say that the electron flow from manganese to X. Electron flow from manganese to X. So they're saying that which one is an anode. Remember that you have too much electrons here, meaning that, and oxidation, meaning that manganese, and then this is X. Yes, the electrons flow from here, and then they go there. You see? Yes. So meaning that manganese is the one which is the correct answer. Use calculation to identify X. So in this case, you have to use E cell. Yes, is E naught cell is equal to E naught cathode minus E naught anode. You understand? So E cell, we know that it's 1.1. We know it 1.05. E. Now we know that the cathode, we don't know it. We don't know. Then you just put X and then minus the anode, which is manganese. You go to the reactivity series, you'll find manganese there as 0.13. So now in this case, you find the X. So X is equal to negative 0.13. Yes. Did I say that? Negative 1, negative 1. System is jamming. System is jamming. Okay, it's negative 1, let me just minus negative 1, 1, 8. Let me show you what I'm meaning. Then when you subtract, this and this becomes positive. When you put it this side, it becomes negative 3 volts. And then when you go to the, you'll find it as lead. So this is what I'm saying. Yes, you see, it's here, the value you have got. So it means that it's lead. Okay? Yes. And then when we found it, because there is oxidation in there, so that's what I was trying to say, that figure and that figure. So we ended up having yes, identify it as this. You see that we found out that 0.13 volts is lead. So we have identified that mirror X. The thing for this, write down the standard conditions. Standard condition, guys, are always the same. Temperature, which is 25 degrees C or 298 Kelvin, 1 atmosphere, and then 1 mole per decimeter cubed. Always, guys, always. Those are the standard conditions. State cell notation, in this case, cell notation. So in this case, we're going to see that basically we have manganese, because we said manganese is under oxidation. Therefore, manganese, which is a solid, gives manganese, is oxidized to iron. Yes, this is aqueous. Then salt bridge, lead is reduced to ions, gives you lead ion, which is a solid, like that. So that is the cell notation that we are looking at. And then half equation, half reduction, half equation, meaning that what is being reduced. Remember that X is lead, which is being reduced. Therefore, it's going to be the same thing here. What you see here is PB2 gives you PBS. So now, because this is reduced, it means that it gains 2 electrons. So this is a solid, and then this is aqueous. Basically, that's how you're supposed to write that answer. Then the last question, the last question, they're saying that a diagram draw represents the purification of copper ore to produce copper, and the cell also contains zinc, silver, and platinum impurities. The graph shows the initial relationship between mass of copper and deposited versus the time. Okay. Yeah. Question number 1. Write down the energy conversion in this. This is an electrolytic cell. Therefore, is electrical into chemical. Which electrode AB would copper be placed? With pure copper placed? AB, yes. They're asking you. We come back here, and then we see. Check here. This one is the anode, because this is the electrolytic, which is positive, and this is the cathode. And then we say that this is reduction, or this is oxidation, and then this is reduction. So we go back and then find out what are they saying. They're saying at which electrode, A or B, would pure copper be deposited, meaning that it's going to be reduced. If you put pure copper here, pure copper, it's going to be oxidized. Copper 2 ions plus 2 electrons. These electrons, they're going to move this side. When they come this side, they're going to react with the copper. Understand? These ones, they're going to react with the copper, and then you form copper 2 ions plus 2 electrons gives you copper solid, and then the mass is going to increase. So meaning that the answer is B, because they are saying pure copper, where is it going to be deposited? So it's going to be deposited on B. And then they are saying that write down the half equation that takes place at the anode. Half equation that takes place at the anode. Hello, sir. It comes to electrolysis. I have hard time answering questions about relative strength of either oxidizing agent or reducing agent. Can you please emphasize when reach that question? Yeah, I've already finished it. I think you need to watch one of my videos where I was trying to explain it very well. But I'll try, after finishing the last question, I'll try to maybe to emphasize it. Ne? Yeah. Tapero, ne? Yes, I'll try to just to give you a small technique how you can spot it out. Okay, they're saying that write down the half equation. Write down the half equation that takes place at the anode. So that oxidation, definitely I'm going to have copper, solid, plus 2 electrons. If they are being oxidized to form, no, man. Copper 2. Yes, it's copper, but just I'm putting electrons in the wrong way. Copper, it gives you copper 2 ions because it's oxidized from 0 to positive 2 plus 2 electrons. Why do you add 2 electrons here? So I cancel that if it goes back to normal. Yes, this is a solid and then this is aqueous. So that's what you're supposed to write in there. And then I'm saying that will the gradient of the graph be affected as the reaction allowed to produce to proceed until completion? No, it will not. It will remain the same. Why? Because the copper will keep on being deposited. Yes. Refer to the relative strength of reducing agent. Explain why zinc will, I think this is the question you're asking. Refer to the relative strength of reducing agent. Why zinc will not be deposited at the cathode? Why zinc is not going to be deposited at the cathode? Let's go to the reactivity series and see which one is on top. Hey guys, let me tell you this. Ne? Don't use the two this reactivity series, ne? Because there is that and there is that. Choose one which you master. Ne? Okay. I always tell my students to use this one because this is the normal one, the other one is the reverse. The one where you see lithium on top, use that one. Whenever you see lithium on top, use that one. Because the one which is on top, now the one which is on top is going to be more reactive than the one which is on bottom. But if you use this one, the one which is on bottom is going to be more reactive than one because the lithium is now down. So use that one which has lithium on top. Meaning that if the compound is more reactive, it cannot be replaced. It's the one which is going to replace. So now you are comparing zinc and then you are comparing copper. So you're going to have to look for zinc and you'll find out that zinc is on top and copper is on bottom. So zinc has to reduce copper. Copper can't reduce zinc. You see? Yes. So meaning that zinc is going to be oxidized and then copper is going to be reduced. Because to be deposited, it is supposed to be reduced. So copper cannot be oxidized and then the zinc is reduced. Never. Why? Because zinc is more reactive. Therefore, what it does is zinc is going to be oxidized to give zinc 2 ions plus 2 electrons. Because this one, these electrons are going to be obtained by copper. Yes, you see, by copper 2 plus these 2 electrons, and then you form copper solid. You understand? So why? Because zinc is more reactive. You cannot go to someone who is rich and then when you are poor and then you give a rich. No, it's the rich who is supposed to give a poor one. You understand? Yes. So zinc is more rich, is more reactive. So it gives out electrons to copper, which is needed. It is in need. So when you look at zinc here, you find out that zinc is here. What about copper? You find copper down. Check. Copper 1 to copper 2 to copper 1, or copper 2 to copper. Check where it is. So it means that the one which is on top is more reactive than the one which is on bottom. So the one which is on top is oxidized. Therefore, is oxidized. Because it is oxidized, it causes the other one to become reduced, because it gives these electrons to this other one. So this one is oxidized, this one is reduced. So because it causes this one to be reduced, therefore it becomes a reducing agent. So a reducing agent is oxidized. And then because this one has reduced, it has caused this one to oxidize by accepting the electrons from it. Therefore, this one becomes an oxidizing agent, because it is an agent of oxidation. It causes this to be oxidized by accepting the electrons which is coming from this. Therefore, this one is oxidized, this one is reduced. You understand? So oxidizing agent is this one is oxidized. You see, the one which is oxidized, it causes this one to be reduced. So in other words, this is a reducing agent because it causes this one to reduce. So a reducing agent is oxidized. You see, and then an oxidizing agent is what? Is reduced, because it accepts is reduced, and then it causes this one to be oxidized. I think I'm clear there. So when we go back here, we shall see that the question is asking you that which question was it? 9.5. Yes. So in this case, you see that zinc is a strong reducing agent than copper, meaning that the zinc will be oxidized, you understand, and then gives these electrons to copper so that it reduces what? Copper. That's why you're saying that zinc is a strong reducing agent, for it is oxidized, you understand? Therefore, copper ion will be reduced to copper. That's what I was trying to explain here, that zinc is a strong zinc is a strong reducing agent. Its ions here, its electron will reduce the copper ion to copper. That's why zinc cannot be deposited in there. Yes. So you guys just take one table, the one which has lithium on top, so that at least you don't get messed up. Then they're saying that when current flows for 30 minutes, 15 grams of pure copper was deposited. Calculate the number of moles of copper. Copper, this one is simple. Number of moles is equal to mass over molar mass, of which 15 divide molar mass of copper. What is the molar mass of copper? Molar mass of copper based on the periodic table is 3. It's supposed to be 64, but based on this is 63.4 or 0.5. I think it's 0.5. Copper is supposed to be here. It's 0.5. Yes, it's 0.5. 63.5. 3.5, and then the number of moles is going to be giving you 0.24 moles. Yeah, simple. And then you get your max. Determine the number of moles of electrons. But don't forget that when copper is oxidized, copper to ions plus 2 electrons. If you look at it, it's 1 mole, and then here is 2 moles. Meaning that 1 mole of copper is going to give me 2 moles of electrons. Therefore, in this case, I'm going to say that number of moles of electrons in this case is going to be equal to 2 times 0.24. Why? Because 1 mole of copper gives 2 moles of what? Of electrons. Yes. And then, yeah, basically, that is it. And then you get the answer as 0.472. Boom. You get all the marks. Who got all the marks? Yes. So, guys, that's how the paper was supposed to be. And I wish you guys have been on Thundereduc trying to do different questions with me. I know that you'll get distinctions. If you didn't get a distinction now, don't panic or what. Yes, distinctions are coming. Don't worry. You'll get the distinctions. Make sure that you keep practicing questions. When you practice questions, you'll get what you invest in. You understand? Yes. So unless you have any question, let me check see if there's any question. If there is no any question, really I wish you the best for your final exam. I appreciate that. Thank you very much. I hope Tapero you have got that explanation which I try to give up or to give you the one I said that I'll try to explain it. Thank you very much. It has been M.Saidi as usual. See you in the next class as you're doing final revision.